GenAI, LLM, AGI. Can you debug that for us?
The easiest way to think about reinforcement learning is, in practical terms, think about children. I would argue 100% accuracy. That's what you need to get safely through that, right? And I don't think we are completely there yet.
Welcome to Blackbox Debugged, the Lufthansa Systems podcast. I'm your host, Dzefris, and today's topic is AI, the artificial intelligence. We'll be debugging the topic with Manuel Schmidt. Hi, Manuel. Welcome.
Happy to be here.
Can you please tell us something about yourself?
Yeah, so my name is Manuel. I am the head of the AI enablement team here at Lufthansa Systems. I am now almost since 2 years in the field of AI. Essentially, since my master's thesis, I got stuck in AI and never left the field again, basically. Yeah, my PhD was centered around AI for autonomous driving, for example, behavior prediction and movement planning of these vehicles. And right now, I try myself out in this field of aviation, which is extremely exciting. Like, there are so many opportunities here to apply AI really meaningfully and drive business value from that. And hence, I'm really looking forward to this session here today to discuss with you this topic.
Awesome, great. Let's start from the beginning. What is AI?
Yeah, I guess if you were to ask this question to 10 people, you probably would get 10 different answers. But here is mine. So I think AI has been around for really like a while. And back in the days, you would rather call this machine learning, where you say you have data that you can show a machine learning model, train it with, basically. And then, for example, predict sales forecasts, right? Like what amount of sales will you have during the year? So it's a classical problem in machine learning. And over the years and fast forward up to now, the new kid on the block is basically generative AI, where many people now get exposure to AI. And those type of models, large language models, can really work well with text and help people in their day-to-day and I guess in private life, for example. In a nutshell, I guess what I was going to say is AI is really, on the one hand, the classical machine learning. It's still around. You still have many use cases for that. But now increasingly also generative AI.
So you said generative AI. And I mean, there is a lot of hype around the whole AI topic. And there are a lot of buzzwords. So GenAI, LLM, AGI. Can you debug that for us? Can you tell us what are these words about?
So I will try. I think the reason why the name GenAI was created because, or was, for example, due to the image generation models that you might remember. So you would, for example, feed in a prompt, a text of what image the model should create for you, and then it would create something very realistic. So right now, when you look at those images, it's really hard to tell if this is synthetically generated or kind of a real picture of the world, for example. I think there you can really relate to this character of something is generated, basically, right? The model learns a representation of the world and is able to generate new things, right? Synthetic things, basically. So this gives you an indication of what generative AI means. We already discussed machine learning. There I would always say it's very classical. You have a data set, you have a target variable that you want to predict, right? And then machine learning models kind of do this prediction for you. It can be, on the one hand, one approach is a classification problem where you say there are certain classes. I will give you an example. You have images, right, of cats and dogs. Now you want to train the machine to distinguish those. And kind of on a training data set, you have labeled data of cats and dog images. Now, during prediction time, that's how it's called. Now you give an unseen example, completely new to the machine. And the hope and expectation is that the model learned this properly and can generalize to this new image and tell, if you give it the dog image, never seen, that it really tells you this is a dog, basically. Classification is one, regression is the other, where you try to predict numbers like sales. And the last, which I didn't mention so far, that's another kind of method, basically, is reinforcement learning. And the easiest way to think about reinforcement learning is, in practical terms, think about children. When what happens with children is, let's say, kind of, there is a hot plate and the children touches that hot plate, then it directly gets a feedback, basically. And hopefully, based on that negative feedback, or also in reinforcement learning terms, negative reward signal.
Being burned.
Yeah, being burned, actually, pain. Hopefully, the child learns to not repeat that behavior in the future again. And this is kind of the paradigm of reinforcement learning, where you have a so-called agent, right, interacting with an environment, and the environment itself gives back reward signals. And by thus kind of letting the agent explore the environment, doing actions in that environment, hopefully it learns to make good actions, rewarding actions, more likely, and kind of painful, negative rewarding actions, less likely. And I mean, get a better system, basically.
Yeah, this is, I think, what we all came across by like using currently available tools like Copilot or different chats that are available out there. Right? You look for an answer, and then sometimes you need to help the model. Yeah, or you ask, can you give me a picture of a certain type of a building, or maybe more controversially, a full glass of wine, right?
Yes.
There is a bit of a challenge there. But then LM or the chat tells you, I can't tell you what is the difference between these two buildings or this type of a building you're looking for. Then you have to like help it a little bit, like when you talk with a child, right? You say, actually, you can do it, right? Just please try again. And actually, next time with this like reward system, I guess it gives you actually something out of that. So
yeah, what is important here to distinguish is kind of the training phase and the phase where users actually use these LLMs like ChatGPT. So during the training phase, what really happens is human feedback is actually used in a similar reinforcement learning fashion. During the training, to tune the models to give the right answers aligned with kind of the expectations of the human feedback givers, basically. So how you can think about that, typically what happens during training is you have a certain set of test cases, and the model then is tasked with give 5 options. And now the human feedback giver needs to pick the best one according to the own perception. And that's kind of, in reinforcement learning terms, that person provides the reward signal. That's then, of course, used during training to align the LLM models better to the humans, right? To make this, to also increase the acceptance actually down the line, right? Because people want something that feels good to interact with.
Yeah, so you said that, I mean, we are tuning the output so it's more humane or humanly readable, right? Like, and this is what we've been trying to do in the computer engineering area for decades, right? Just like optimize for better UI, better interface between us and the devices. Can you name a couple of good use cases of the currently available AIs? What is the AI approach that is the best for the software development at the moment, the best reward regarding the or return on investment in this area?
Yeah, let me start by saying that for me, it's really natural these days to interact with LLM systems for various tasks, actually, in my day-to-day, not just work life, but also private life. So, for example, with my wife, or better actually, my wife is setting up a music school right as we speak right now, right? And I'm trying to help there also in my free time. And sometimes I come across certain questions I have, like regarding the placement of the piano, for example, and how to soundproof the room. And I find it very amazing that I can these days just take a picture of the room, of the setting, ask those questions, and get recommendations. And so before that, I would spend a lot more time researching that on Google in various sources. And now I have this sort of system that provides me a consolidated recommendation right away. Saves me time that I now have to play with my daughter, for example, which is quite amazing. When you look more in the corporate world, and specifically you mentioned software engineering, then I see that the tools like Microsoft Copilot, for example, not Microsoft Copilot, in this case, GitHub Copilot, actually become more and more capable with better models, better reasoning. So better models with more reasoning capabilities being integrated there, then those models actually understand part of the code fairly well. And for example, what they can do is they can very nicely explain certain parts of the code for you, right? They can tell you, hey, let's assume I'm a newbie in this code base, and the code base can be really complex, as we know. It can tell me, this is doing that and that task. It serves that and that purpose, basically, because in the background, it also checks where, for example, specific methods or functions are called in the whole code base and try to take all of that context into account when answering. So that's one area. And when it comes to return on investment, I think these are really the areas where you could say internal usage of those tools to increase productivity by using them very mindfully where they really work well. That's important, right?
Not to extract something from the Excel sheet, or maybe do a function that Excel already offers you, right? I mean, I came across a lot of requests from all around, like either like colleagues or friends or like examples where they are like, I can do this now, and I was like, okay, Excel can already do that. You don't need to waste computational power, energy, or even time, because Excel is actually faster doing that than the Copilot. Copilot can help you if you don't know the Excel, right? You can ask him, how can I do this in Excel? And then there is a high probability it will give you a right answer. Because what I came across is also, to be honest, like there are of course still challenges regarding these models. They're far from perfect yet. They're quite amazing. Like,
sure.
I'm also surprised sometimes, like how good they are, and then I'm sometimes really disappointed in how bad they are. And I've tried myself going through the list of emails, and then like basically it started eating the letters from like certain emails after certain, like first 20 were great. After that, it just like went south.
I do fully agree with that statement. So everyone who knows me, either privately or professionally, knows I love simplicity, right? I love simple solutions, in line with also, if you may know, Occam's razor. The simplest solution is typically the best one to go with. I see it the same way also. So you really need to have clarity around what problem you actually want to address in the first place, right? It's go back and go to the problem space, not be in the solution space. And you see, like, I'm actually a very passionate product manager because I do believe in these concepts. So be clear on the problem side. That typically requires you actually to go close to the trenches, actually, where the process happens, or where the customer, for whatever you have in mind, is working on that specific thing that you think there is a problem. Inspect that, get clarity around that, and then only then think about, like, what is the solution that might address that root cause of the problem, or like really mitigate the issues there. What is it? Is it AI? And I have a good justification why it is AI. So I wouldn't buy like, hey, now we need to throw AI at everything. That's kind of not the right way typically. Rather think about, as you said, is it something that's already included in the software tools you're using with 2 clicks? You don't need AI, or obviously you don't need AI. It's just a waste of money and time of everyone to bring that in there. But if you have use cases where you really say there is no simpler solution because kind of the problem has has various uncertainties involved that require reasoning capabilities, for example, of an LLM or something like this, then of course AI can be the right choice.
Yeah.
And in between, maybe let me add in between, I think in between people forget that there is also very classical robotic process automation. It's like if you have tasks that you could write down on a paper step by step, like a cooking recipe, and don't involve uncertainty, then you can also just automate them with classical RPA tools and get the job done that way, typically way cheaper.
Yeah. Right? Yeah. I mean, it is human. It's part, the hype about new technology, it is part of I would say, humanity or a human approach to things, right? Like when you see this new shiny thing or also being scared about the new technologies. Or in the past, we had they're still relevant, some technologies like blockchain. But in the past, a couple of years ago, people were trying to solve everything with blockchain, right? Then all of a sudden, there are most wildest proofs of concept or tryouts that never came to life at the end. And I mean, there is benefit, of course, into exploring, and you need to learn and find out. But applying basic principles, right, on like how you approach to solve the problem still stays there. And I would say, especially for software development, it's even more important to apply good software engineering practices to be sure now this code that you're generating, that you might be understanding slightly less. There is a negative side of it, right? You might be less even familiar with it. To be careful that that there is automated testing there, that there is that there are check and balances there, the guardrails that are protecting you from making some horrible mistakes. We had in the past some lawyers going with, I think there was a case in US where lawyers went with ChatGPT based defense and of a client, and that didn't end up well, right? So we have to be careful there. And then in respect to this, and as we said, like we dissected a bit the hype. What do you see as like 2025, 2026, like the hottest topics around AI? Is it agents? You already mentioned them, or what else is there that you see that is coming towards us?
Yeah, I think it's agents, but notice here already where it gets a little more complicated. When I mentioned before agents, that was a concept in reinforcement learning. There you also speak about agents or actors. When we are talking about agents in a GenAI scenario, then an agent is something a little different, actually. And so for GenAI, an agent is kind of like this. You generally have various LLMs that have specialized tasks. And so like one LLM can be an expert in querying a database, for example. Another LLM can be an expert in generating code for a BI dashboard, for example, right? Now you have these two specialized agents, and they have what is called tool calling. So you already sense from my explanation, they need to have a way to interact with different systems, right? Like a specialized LLM that should query databases needs database access. You have these LLMs that can do tool calling, and then you put on top actually an orchestrator LLM, kind of a team lead, so to say, like specialized team members, one team lead. And now that team lead can decide, okay, I have this task. Human comes in with a specific task. Like I want to have a dashboard for XY based on this data.
Yeah.
And then the orchestrator routes it to the right specialists, takes back the results, sends it to the next specialist until kind of the task gets done iteratively, basically. And there you sense already that has potential because it has more autonomy, but it also comes with risks, because you see kind of giving this autonomy to those systems, that's really tricky terrain. And you would want, I think, for the near future, for sure, probably even longer, to have really good human oversight, because as you mentioned, those systems are not perfect yet. And issues that, for example, the first specialist LLM would have, errors, they would cascade down basically, and they get worse and worse. So that can really work also very poorly, to be really frank. So
I mean, if you take it out of the domain of software, in software, of course, we have seen this before, the complexity of it, right? Distributed systems, this is like distributed AI, and then now you're having orchestrator, and it's like you have microservices architecture, and then you need to somehow align these services, and there are many other examples there. So this is added complexity that makes the whole thing harder to understand and to make sure that it is giving you what you expect, right? So, but there is also a value in it. So there is a risk, right? There is also reward there. Where, I mean, for example, if you go now more into the other area, for example, with like radiologists, I think this is also very, very well-known case. There were some predictions for a very long time that they will be completely replaced, right? Like radiologists, like many years ago. However, I think in that space, and it's also regulation area as well, like regulated industry, so on, it's like AI can enable, or the software with AI can enable radiologists to improve the outcome. So to improve the life expectancy, to be able to react and detect tumors, for example, on the CT, on MRI scans, with better accuracy. So if currently they have 80%, maybe they can do 82.
Yeah.
Or, there's another option, right? You can rely on AI, and then AI can guess it 90% of time, which is still better than the radiologist. But this hybrid, personally, I find this hybrid model something that I would prefer, right? Like I would like to have human empowered with AI. And this is, yes, there is a risk. A doctor can also make a mistake. But if you combine this, you're improving the probability of a better outcome.
Correct, yeah. Because the lower bound is now the 90%, and it can just be better. And I agree. It's for the foreseeable future, for me personally, my opinion is that we'll see these hybrid settings.
Mm-hmm.
Because humanity, and this gets rather philosophical, but you can think or listen to Harari and colleagues, like where it's really unclear where this then would go if we give too much autonomy to AI, basically. Because with this agency and autonomy, so it's like, what could it do to financial markets, for example? And that's kind of the existential basis for us humans here. So I think one needs to be careful there. And in practical terms, anyhow, I see right now it's more of a co-pilot thing. Human is the decision maker.
The driver.
Is the driver.
Yeah.
Tasks kind of the system with something, gets help, very, very good help oftentimes, and hence is better in doing and achieving good outcomes. That's how I see it, and I think, and I hope it will stay that way for long enough.
Yeah.
You mentioned good cases. That's true. I think there is potential to make our lives better with this technology. But there is, on the other hand, the other side of the coin too, where, like, if you think about the prohibited cases in the EU AI Act, where people can really be also put at a disadvantage, or it can really also be put into applications where it is actually intended to harm people, right?
Yeah.
So
I think currently there are like two approaches right now. We have like, or maybe there are even three. So one is US, the EU, and China. And I would say at least these two, US and European one, have different approaches. US one is more of like cost benefit kind of approach, and EU is more like risk reward approach, where like EU is regulating it more in the sense of like, okay, no credit course based on AI, but okay, on the other side, LLMs, this is fine, and then let's find the middle. Let's find the good use cases here. So there are these two sides here, and like in US currently, I feel like it's more driven, like it's really open, and let's see where it goes. Right, both sides can go somewhere. But what do you think? will it lead to AGI? And what does AGI mean to you? Or for you?
Yeah. Well,
how do you define AGI?
That's a really tough one. Like,
what is AGI actually? What does it stand for? The abbreviation, right? Like,
yeah. So AGI stands for Artificial General Intelligence. And now it gets already really tricky to define that. So
what is intelligence?
Yeah, what is intelligence? What is general intelligence? Then there is also the term of ASI, artificial super intelligence. I think that is. I'm not really honestly taking these conversations too seriously, because it's like, as long as we don't have a clear definition of what that even means, for me, it's just potentially another buzzword for now, unless we can make it very concrete. That is, like, it needs to pass whatever kind of these, for example, Turing test, you put AI system with voice output behind a curtain, and then you interact with that, and you couldn't tell a difference. But then I would argue, is that really already AGI? Do you need to maybe also manipulators like we humans do? Like, we have our hands and our thumbs, and that makes us kind of very special on this planet. And that makes us a very universal being here. And if I just look at an LLM, like, it has none of these type of things.
Unless you combine it with robotics.
Exactly. Right now it's a knowledge store. If we talk about robotics in the future, embedding these systems into robots, right? And doing my studies, I was at a chair where we do robotics control engineering and stuff. So I've seen this firsthand, and autonomous drivings, autonomous cars is actually just a robot on wheels, right?
Yeah.
You see that it can be really powerful, but I don't know, coming back to this question of AGI, what it is, I would have trouble to really answer that properly. Maybe it's something with agency, with manipulation capabilities, where you can't really say, well, that's lacking behind the capabilities that we humans have. Like, it's as good as us humans potentially in more or less every aspect. Then I would say, well, that could be AGI. I couldn't be more concrete than that for now, honestly.
Yeah, I think that overall we as humans also tend to underestimate the human capabilities, and it's why we are all different, and we have different levels of emotional, of intelligence, smartness, IQ, whatever you want to call it. And just what simply means moving the hand. This is like very efficient what I'm doing right now, and just for AI to figure out that to train it costs quite a lot, and then you have computational power for it to process, right? Yeah. And this is where I would come to a question. So you mentioned autonomous driving. Would you yourself, with the current status of AI, like the top-notch AI that we have, would you go back on the last seat of your car, open a book, and let AI drive your car all the way from Frankfurt, where we are today, to Istanbul?
It's a long ride.
Yeah.
I would love to sit in the back seat, for sure. Would I trust that? So I have been doing research in that field, right? Doing my PhD. So I've seen kind of the ups and downs in that field, and know sort of where the technology is there. And I have still friends that are researchers as we speak on these topics of, for example, movement planning and things like these. I would argue that technology-wise, there are still limitations. So I could not sit on the back seat, because simply if you think about the variance you have and the uncertainties you have in the real world actually out there, that, I don't know, like a new construction site is just created right there, and the lane markings are just all over the place. And now let the car and the AI figure that properly out with, I would argue, 100% accuracy. That's what you need to get safely through that, right? And I don't think we are completely there yet. So can already be like the camera doesn't detect that. And then you're missing kind of important clues. And then you have a wrong decision of the car, and and then disaster can strike. So for me, it's just way too uncertain as of now with the current technologies, that I would say you can already fully trust those systems, and you can speak of level 5 self-driving in the next years. I don't buy that anymore. Let's say like this.
Yeah,
but let me add something more. Like if we talk about very concrete scenarios, defined scenarios, like we're talking about highway driving, kind of from the highway entry to kind of the exit, hopefully without crazy construction site in between that cannot be handled well.
Yeah.
Then I think it can work well because it's a structured environment, lane changes and all these things, they can work well. But even there, you can never be completely sure, because just say like by occlusion, Porsche driver with 300 kilometers per hour was not seen.
Yeah.
And that decreases extremely the safety buffer you have when you do a lane change and you didn't see that car coming.
Yeah.
And then, what happens?
Yeah, I mean, as humans, we are also not that great, I would argue, in driving. I mean, overall feeling when you're in traffic, because people make mistakes. But at the end, I mean, we all go every day to work, right? And then most of us, huge amount of us still make it intact, right? So we are also not perfect, but I'm also there with you. I would still not feel in ease, like for a very extended period of time, in uncertain areas. If you go down in Southern Europe and then like all of a sudden the markings are a bit worse than they are in Germany on the highway. And then in the data set, there was no this sign ever that is there, right? And this, if you go back to the coding or like software development, this also goes with like very popular thing today is like translating your current code base from the language that you have, probably very legacy language, probably something you have custom made a long time ago, into something more that is current and modern at the market. I've seen it also not work very well there either, like to the point where it's basically faster if you do it yourself and you rewrite the whole code base like that.
Yeah.
Do you see the same way there?
I would see it the same way there. The reason is, when you think about how these models are trained initially, it's as follows. So it's, to me, not a big surprise that they're for example, in the well-known languages like C++ or Python or Java. Why? Because there is a huge bulk of information that you can train with. And programming languages have the nice benefit that's a clear-cut syntax. Like it's fairly clear how you do things in programming. That helps kind of these LLMs to train well on those. Also, additionally, what you also have a lot is like, you don't have just program code, but you have, when you take Stack Overflow, the old days of doing programming, like copy pasting stuff.
Yeah.
You have also text. So someone has a problem, and the best rated answer is typically the solution, and it's one of the best solutions you can have, because people like to contribute there. So you have, if you talk about one language, you have text as a description, and you have a code example. Now you can very nicely train the typical use case of that. You give a Copilot, GitHub Copilot, hey, I want to have this and this and that, give me code for it. It's kind of what Stack Overflow did for you in the past, right? That works well. When it comes to translation, you would want to have in the training data set something like, hey, I have this code in my language, Stack Overflow for programming language translation, basically. Like, I have this snippet in the source language, I want it in that and that target language. And then hopefully someone comes, oh, hey, I have here kind of the answer for you. This is kind of the code snippet and it's translated. Yeah. But you don't have that as much.
Yeah.
Especially if you talk legacy languages, there's not even a lot of examples for those.
Yeah, and you're going through different paradigms, right? It's like some of them are like, you're going to maybe to object-oriented language, or from functional to object-oriented, or from, I don't know, like if you go from something like COBOL to Python or Java, like it's a different way.
Yeah.
How they're structured behind. So it's not just syntax; it's like the whole logic behind that, how it works, right?
Yeah.
And then, of course, you have to do it. I wouldn't expect it even to work without human intervention, but sometimes it's just like so off that like basically just do it yourself, right? So you agree there. And I mean, yes, sorry.
But let me add something more there. So I think while everything we talked about, it's fairly clear it won't work as great. But I think surprising enough, in some cases it will work, and you might then ask, like, why actually? Why might that even still work?
Yeah, why?
Right? Why that? And I think the reason is that these models generally learn a abstract representation of programming itself as a paradigm. And if you think about reasoning models, what reasoning models are these days, like O1, O3, you might have heard of those.
Yeah.
DeepSeek, R1, is like they do things iteratively. You start with a query and they create first response, and then they check it themselves, basically, in the second iteration. They're like, okay, this is the query, this was my answer. Does this make sense?
Yeah.
And then they iterate, and you can actually in research see that the longer you let them iterate, the more money you spend, by the way, of course, but actually the better the results typically get. That's why in OpenAI you have these reasoning times, I think, like low, medium, or high reasoning effort, maybe it's called. Anyhow, where I want to get is that if you still start with a legacy language in a reasoning context, it might be that first step is the reasoning model will try to translate it to a description in text that is fairly good.
Yeah.
And if it can do that properly, then now it's the next step to convert now the text input. Now we're back in the Stack Overflow setting, basically, to programming code.
Yeah.
And that can actually work sometimes. So it likely will not work as good as for just create popular language code based on text. But if the initial source language is still represented fairly good in the training data, there are chances that it works somewhat.
So we need a good data sets that are available that can be then used pretty much for AI to have a good outcome.
And that's really it. So if you see, you could think about, like, why are there even differences between OpenAI, ChatGPT, and Anthropic's Claude, for example? Why is that? When everyone can sort of train on the internet, basically. It's around the processing of that data properly, filtering that data, for example, to remove the unwanted stuff, and then kind of also this alignment with the human feedback, basically. And there comes the differences. When you talk about AI, I think you actually always need to first talk about data, because people really need to understand that, like, if you don't have proper data and you don't have means to quickly access also data because it's all over the place potentially, then building AI use cases on top of that becomes extremely difficult. Like, the value or the delivery speed you will have when you don't have the data in place will be drastically longer, right? The lead time to deliver value, basically.
Yeah, incredible things are happening right now, and I'm also really looking for the future to see where we are getting with AI. Manuel, thank you very much for debugging the black box of AI today with us, and hopeful to see you in the future. It was a pleasure talking with you.
Thanks very much. Enjoyed the talk, and likewise, would be happy to be here again.